evening. Good evening, all. YouTube Studio. Go live. Hello, hello. Hello, hello. That looks nice. Is it a good place for my face? It can be way up here. Put this up here. Come on, come on. Is it big enough? All right. What I'm currently doing is optimizing. We're adding optimizations to our basic block IR. And right now, we're doing some control flow graph calculations, trying to eliminate some dead code, do some things after we've inlined some function calls. And immediately, currently, we are looping infinitely when trying to compute the CFG. So I'm currently changing how I compute the CFG because it wasn't handling loops correctly, and the way I'm doing it now is not handling loops correctly yet. Use buffer. It's my 9th no commit to reuse a buffer, but it's important. And let's just we need a visited set, because when there's actually loops, we're determining reachability by actually following all the jumps, and that's the only way to detect that a loop is unreachable. Previously, we were iterating over all the basic blocks, and the thing about a loop is that even if no one goes to it, it goes to itself, and so we saw that it had predecessors and we weren't eliminating it, and then when we went to generate our final code, we were creating empty basic blocks, if that makes sense. So the goal is to eliminate even these dead unreachable loops, which means that instead of iterating all the basic blocks, we need to walk them in like CFG order, more or less, to figure out what reachability means. And that's what we're doing right here. And if visited, we could like insert, right? I always find it's always awkward. Insert returns whether it was newly inserted, right? So if not visited.insert, we can ask, we can just skip it. We've already been here. Yeah, I think that's fine. I think that's all I really needed to do. And we're going to run our small example program here. Woo, and it worked. This is exciting. So here is the code that we're optimizing, by the way. Before, is it before? Yep, okay. So before, say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 basic blocks, and a number of them are trampolines. A block that contains only a jump. We don't need to jump to a jump. It looks like we've chosen to remove 2. I feel like we could have removed more. Yeah, this says simplify end, and the trampolines are still in here. That's sad. How long does it take to understand everything that's happening here? I don't know. Probably a couple of years. Depends on where you're starting. The nice thing about IR like this is it's actually very simple code, and that's its purpose, is to be simpler than source code. But the cost is that there's more of it, and it's much harder to understand the whole program. So we have to be a bit myopic and LLMs are actually great at reading assembly and IR, because they can kind of see the patterns in it that we can't, because it's so like voluminous. Kind of like how they can read base 64. So yeah, we still jump to jumps, but at least everything's working. And I suspect that might be because I just commented out my CFG simplify. I might have just, yeah. So I added removing trampolines, but I commented it out. Why did I comment it out? I don't know. This has been a bit of a mess. So just resolved to make a mess before I fix things. All right, so running the full test suite now, we're down to, we made it pretty far, I think, and filled in does not have a terminator. So that probably means that we didn't go to it, but that we also didn't eliminate it. So this is the bytecode we were compiling, and it says while loop body doesn't have a terminator. So as we can see, it only precedes itself. So this while loop body, here's the entry to the function. We have this while loop body, and its only predecessor is itself. And if we search for this block, we just see it again. So no one else is mentioning it. This is correct. So this is what I was mentioning. So, but now that we're traversing things the right way, not CFG simplify, but CFG compute. Right. Okay. I kept my old way of iterating together with my new way. So that'll do it. Yeah. This needs to be commented out for now. And everything passes. That's like 5 or 6 nights of everything being broken coming. So it's a big one. We'll take the win. Huge. I only have like 19 to-dos and 9 no commits to clean up. But I think that core algo is going to work. So let's see. We have this. Can I pass all of the tests, not just the big test suite? So this will add the standard lib one that was failing. Rust takes forever to run no unit tests. I don't know what's happening. Cargo, I guess. We did it. Everything passed. I don't think we need to log these, do we? It's a lot of visiting. Boom. This is really exciting. I don't know if I have a lot of advice for how to get into compilers, because I'm just someone who wanted to get into compilers. What compiler are you making? It's for my own language that looks a lot like, it's a good example. We'll go to our JSON standard library. It's a systems language that looks like this. So here we have like a discriminated union sum type that's kind of rusty or OCaml or Haskell, whatever you want. And then here's a nice little struct that's a little bit, this is pretty C-like. Some methods on it. I'd say this feels a little bit Rust-like. We have type classes and abilities, so that's very Rust Haskell-y. And we have full compile time execution, which is very, I guess you could say Zig, maybe you could say Jai, but I do it a little bit differently than both of those. And currently what we're working on is optimizing the IR that gets run at compile time so that metaprogramming doesn't cost you too much compile time. The other thing we do is we're very explicit about allocators and where things live and how memory is managed, because this is really important for making things fast these days. So in that way, it's a lot like Zig. I actually have an LSP, but it's choosing not to start, which is a little bit sad. Yeah, I'm not sure. We have a VS Code plugin and a NeoVim plugin, and it's actually pretty nice to work in the language already. Thanks for asking. But yeah, I think that the way to learn is just try to start making a compiler. Honestly, you just have to start trying to make compilers. I think it's really by far and away the best way to learn anything is to just build. And if you can, try to build something and stick with it for many months to a year. All right, but that's not what we're here to do. We're here to clean up after all of the mess we've made. So yes, the other thing, we got to re-enable trampoline removal. So in CFG simplify, our trampoline case says if a node has one predecessor and it also has one successor and it contains only one instruction, and that's a jump, then remove that node and rewrite every instruction that is going to it to go to its successor, and rewrite everything that's talking about coming from it to come from its predecessor. Yep, because that's where we'll be coming from. Let's give it a go. Okay. Okay. Current function blocks. Well, we should definitely have one. So once we add trampolining, we fail here, and we fail to find block 566224. And block 566224. By the way, these are not how many blocks we have. These are byte offsets into our arena. So they're like pointers. Yo, what is good? This little Friday night IR wrangling. So why would we fail to know about a block in CodeGen LLVM? CodeGen function body calls CodeGen unit body which walks all the blocks, yeah, and inserts them into our mapping. So it must mean that an instruction 566224 is talking about a block that is no longer 566224. We've removed it. And we delete a phi incoming mentioning it. And then this is the end. But there's still a pred. So this guy still thinks he has a predecessor of 56224. And this guy still tries to jump to 56224, which is very wrong. Yes, I'm making my own compiler. This is a part of it. We have a fully functioning, systems language with a lot of features. Not ready for anyone else to use yet, but hopefully sometime this year. So this is post. The entry goes to 56224, which it does, but we've removed it. So that just seems super wrong, actually. Let's go read. So before optimizing, I think this is the same one. We'll look for 56224. There it is. And it is a trampoline block. But we're not successfully. Yeah, you jump into it. Where's the first mention of it? You can really start off making a compiler in any language. All you really have to do is write a program that takes text in and then executes it in some way. So if you write something in JavaScript that takes in equations or math expressions and evaluates them, you've written a compiler. The rest is details. There's not really a best one. Great choices are Rust, C++. People say OCaml. If you don't want it to be fast, then OCaml. So what are we doing wrong? We're trying to remove a lot of trampolines. And it looks like we just need to rewrite the CFG. No, this jump if still mentions it. So that's there's no way that's correct. So we've rewritten. We didn't add a block delete. Removes, but removes adds a block delete. And then we've set no op to. No op has to be false. Yeah, so my compiler is currently written in Rust, but most people, once they're happy with their language, they rewrite the compiler in that language. This thing is still mentioned from this jump if, even though we're removing it. So why does it not get rewritten? That's a block enter. Am I crazy? Removing 566224. That's happening down here. Delist remove. And we rewrite everything, and then we CFG compute, which clears everything. That's cool. Converts JSON to WebAssembly. Each pass has its own. Let's do this. Rewrites dot eprint. Simplify pass. I mean, this should be a simple one. What are we getting wrong? We just do a continue. Do we try to do too many at once? Five, six, six, two, two, four. Wow, okay, so it's trying to do all of these removes in one go. So every entrance to 566224 becomes 566352. And then everything referring to 566176 becomes 566224. Yeah. So what I think we should do is once we find an optimization, I think we should just not continue, but break. Which would let us actually do the work in line instead of afterwards. And then we're going to do our thing and return not no op. This will be slower, but maybe not really meaningfully. Okay, well that's worse. Man, I could have just taken the win, but I really want the trampolines gone. It sure does. Well, that's all kinds of wrong. This is embarrassing. 2 preds of 62192. It does jump to match end. What? Let's make sure the rewrites are fresh every time. Yeah. So on the first pass, we only rewrite block exits, which would mean merge with successor. So we do a merge with successor of 62144 to 62024. That looks right. We merge those together. Then we remove 62144. Okay. And we do that because it's dead. But like we could do that in this merge case. But what we choose to do instead is kind of like mark it dead. I mean, I guess that's fine. Okay. Okay. And then we merge 62616 into 62192. And then we remove 62240. Why do we do that? Move 62216 into 62616 into 62192. Okay. Because your successor only has 1, I guess? Yeah. And then we're done, and everything is broken. Man, everything's working. So maybe we remove the trampoline case and kind of come back to a state that we had that was working and think about if a node has 1 predecessor and 1 successor and it's just a jump. We can remove it. Yeah. Are things with my other changes, are things still working without trampolining? Yeah, they are. So I think, blessedly, this is just doing something wrong. Let's see if we can get a free W here and ask the clanker. What's wrong with the trampoline removal case? With it enabled, everything gets fucked. Trampoline case is missing a loop guard. I don't think I have. I don't think I have. I don't think that's what's happening because... Whoops, this is the correct version. The function it's failing on did not have a loop. I don't think. Let's try. Yeah, there's no loop. It's just a simple match. This is pre-simplify. Yeah. Well, we'll give the clanker another try with this output. Well, what we'll do is we'll say trampoline we'll do dead and this isn't how we want to do no, this is fine. Empty preds in this case will be fine, I think, but it would be better to just like say in compute CFG if we never visit. No, it's fine, it's fine. Okay, and then removing, and then this is the merge case, right? Merge into okay. Run it again, get some logs. See what the LLM has for us. It's grow, by the way. It's grow, the function that we're failing to compile. What? Oh. Grow, it's this one. This is the function that we're failing to compile. New cap equals if soft buffer is empty, if else. It's just an if inside an if. Nothing crazy. Right? Yeah. Did I get it? No. Now maybe we'll continue the same one. This is what it does. Where does it corrupt things? Let's see. It's usually wrong, but sometimes it's right. B62760. Yes. True. Earlier you also removed 664. We did. Oh, is that the only problem? Is it correct otherwise? No, I mean, obviously, I knew this was bullshit because they're different and they're coming from the same. Sorry, the end result. The values are different. Which one's correct though? It should be 1 and 8. Yes. Value 1, value 8. Mm-hmm. No. So we have like a diamond. And we're removing the thing is, I need to visualize the CFG. This is crazy. Sit down. Go get more water. You know, I guess I need to dot viz the CFG. There's just no way. So this guy, there's a 1 path and an 8 path, and that's if the capacity, if it's the big element branch, right? So, and what we do is we would say that we can eliminate all of these. The LM size 1 path. Yep. You get merged into here. Oh. But this is a jump if, right? So, and then it becomes not this, but it becomes 62888. So I have 62888 here. And then that remains the 1 path. Right. Yep. And then this guy, 62712, would get merged together, would disappear and become this one, 62760. And then we don't rewrite anything yet, so that one can be removed. And now 62760 is what we would see here. Yep. And so this would be an incoming 627. One, two, with 8. But then the problem is we're left with 62664, for example. And we try to remove him too. So we can remove some of these, but not all of them. So maybe there's something to it. Sure. Well, we know it's invalid because obviously it's invalid. When the successor has no fee that cares about the trampoline, it's just, I don't know if that's true. Or when the predecessor doesn't already have another edge path, yeah. Fee incoming is by edge, not by predecessor block. Yeah. So it's because it works too well. Let's try it. Some suck. let mute suck has fee. Sure. So the suck, we have the handle DL node. That should be the block ID actually. Handle, yeah. Right? Did I do it? Oops. Maybe. This is the one place where I don't mind rightward drift because I feel like it stresses the conditionality of this thing. Only if these 4 conditions hold, and then you don't really mind if the core of what you do is now like deeply indented. But it's when like the main path is down here that's the problem. Well, that works. Just avoid, don't do it when the successor has a fee. Oh, and it's still massively simpler CFGs. Look at these. Oh. Let's go. You like Alicas? I heard you wanted some stack memory. These are all auto-generated source locations to pass to assert, actually. No big deal. I feel like we could like make assert. I don't know how to do it better actually, but I do want to fix it. Man, all right. That was it. With just test with inlining. Right? Or is just CFG simplify. Do I even have inlining on? Shit. Doesn't matter. We'll take the win. Yep, all passed. Okay. Let's do something about all this printing. Ready? So what's the noisiest thing? Obviously, major noisiness in simplify blocks. So we can fix that. Run again. I think that CodeGen is printing a lot. Optimize verify, right? I had this verify module. Map error. I don't get the error, but we can. This would be like write failure file. Is that okay? That's fine. Whoops. I'll take that. And then not verify module, but we can dot verify. When we verify just the function, self dot file, right? What do I even call it? Write failure file. Return error. Do I have a function span? I have entry span, I think. Does our unit have entry span on it? No. Please report it. It's just me. All right. I think this is worth doing because we're gonna hit this all the time. So let's just get a span. We have a function ID. We have a function ID. K1 get function span. I think that this, yeah. We're being lazy. We're being lazy. It's cleanup time. Stop being lazy. Function failed validation module is written out. Sure. I used to fulfill fees later, but now I don't need to. Don't need RPO order anymore. Let's reuse these. So we have seen and post. So result. Okay. Seen and result. Mem take. Scene. Oh my gosh. Those are big types. Blocks. RPO. Scene. Take blocks RPO. Just reusing some buffers. Don't worry about it. We gotta make them. Does it know? Buffers. buffers. CG buffers. CFG scene. CFG blocks RPO. Okay, fine. I'm fine not to pre-allocate this. New, we'll just let it grow because it's only gonna have to grow once. I mean, we could at least put like, I don't know, we could just put like 16 in here. I think we need to import that, yeah. The FX hash thing. And now we would just say self buffers. Oh, we have to restore them and we could fail. But if we fail, we're done. So we restore them. That's how we do it. Now we will we'll reuse the same memory every time we have to do that. It's not called post, it's called result. And I don't think we have to ref mute it anymore because it already is. And we'll go ahead and call u result. And we don't return anything. And you don't return anything anymore either. It's true, we don't need those. Let's just walk through our changes in this file. We're gonna have to deal with these in the interpreter. Am I still producing these? I think I am. Let's see, let's run the tests. How's everyone doing tonight? All 5 of you. What are you currently programming? And how is it going? Yeah, I mean, we fail our own validation. Do we? We fail our own validation and then this thing complains. Yeah, because we have a fee here. Where are you? Not you. Not you. Where is it? My gosh. Am I crazy? There it is. This one. Which is just to self. 426704. Yeah. All right, this is a hack. We need to fix me. Our IR still spits out bad fees that point to self, your own block with one incoming that points to their own block. We just need to rewrite them into values. Yeah, I'll leave that as a no commit. It's a bit of a mess. Okay. That needs to go back to a debug. Wow, though. Look how inlined. Okay. Yeah, maybe, I mean, when does this actually get created? When we inline. So I need to fix it when we inline. When we inline a fee, yeah. This is like no. When we inline a fee, rewrite it to value. And I think that's gonna fix it. Okay, let's just clean up our logs. Try to, and then take inventory of to-dos, call it a night. IR unit failed validation. Incoming block cannot be self, yeah. IR unit failed validation. When are we calling validate? Let's just skip, let's skip reporting that error so that we can continue cleaning up. Okay, deleting fee inc. Commit, yep, I have a total of 4, one incoming. One incoming, actually, note, this can produce an incoming, but that's not considered invalid. The problem comes once we inline those. Okay. Mostly cleaned up. Typer, IR, optimize. We don't optimize before executing. This is probably going to break because I don't think that our interpreter, oh no, that's okay. CFG is not computed. On simplify. Okay, so who called simplify? Optimize unit called simplify. CFG compute on unit. CFG simplify calls CFG compute. I think I intended for it not to though, so that's fine. Let's just continue with that. So you have to call compute. But we could do one on the unit. Unit ID, IR unit ID. And what that's gonna do. Sure. Yes. In that way, CFG simplify, yeah. I think it should. Inline calls doesn't look at the CFG stuff at all. Fix me. Yeah, I know about that. That's bad. I'm gonna get param value. So there's no params. Okay, so we're not quite ready to optimize. Enable optimize here. Because get param value and resolve value, exec loop 1083. I wonder what unit that is though. Just more reuse of buffers. Yeah, I think that's true. Because we're rewriting the exits in the if we didn't do this, does everything still work? Better to have less code, I think. Okay. VM, what happens? Which unit is it? This guy. Someone's trying to reference a parameter. The index is 1. So P1. We have inlined the hell out of this. From meta defins. Oh, we executed a few things before we failed, but not too many. Yeah, there's no way that's valid, that those are both RVO, that all of that is RVO completely. These things are all being returned? Metadefins line 8. What in the world? It's this one. The heck? It inlines the whole thing, which is cool. P0, P1. Oh, I didn't, I didn't fix this rewrite thing. No, I did. But maybe the type isn't equal. P0. I could revert the way I do these rewrites. Why does funparam even need a type? It's not used there. Oh. And just like that, because we don't know. We don't know the value kind. But I know the unit. So that what's happening is we're mishashing these because they include a type, and not all types that are the same exact bits. I could write a custom hash, right? And go about it that way. We have a bunch of values that include a type, though. Kind of want to go back. Oh, man. my replace value instead of using a hash map to actually just match on both. That's tempting too. Yeah, but I don't really want this in here ultimately. But maybe that's the best way. This set ends up pretty big though. How do I know? Yeah, can I confidently do this? Same global, fine. Do you want to be on the stream? Param index is the same. Data 32 of the same type. Yeah, maybe I'd rather just write my own eq. It really stinks that these aren't. Yeah. For the purposes of rewrite, all right, I'm gonna change it back. I had it as insters and fun params. Oh no, but the reason I changed it to values was for the fee rewrite. Yep. Let's do it this way. Yep, and this function becomes for old, new in mappings dot values match old Oh, this is just so much slower. Huh. I don't think that's what I want to do. Because all I wanted to be able to do was rewrite an instruction to a value. maybe that's all I needed to do. Instruction to value. And then this was an option of I think that's how I had done it. Inst ID equals value. Yep. Mappings dot values get inst ID. That's the one. The fun param is going to be an absolute pain in the ass. That just wants to be an instruction now. This is different. This is just going to be rewrite map.funparams sum where is it? Call args. Okay. That instruction. I gotta say, like, once you get into rewrites and optimization, it's like way harder than just compiling. No, I hate that. I'm not going to do that. Okay, and then rewrite inster is wrong now because rewrite value actually needs to be a match because it could be an instruction, in which case we do want to do this, but it could also be funparam index, in which case, what did I do wrong? In which case, let's params mappings.funparams then rewrite the value. And done. That might be better. And that will fix, that should fix the VM bug. Now, I don't want to forget. Whoops. We just re-enabled optimizations before interpreting. Okay. I think we did it. CFG is not computed. Yeah, cool. We got to code gen. That's amazing. So we interpreted all the optimized IR, even without the fee fix. What does what do you do for a fee? Uninit. Ooh. Let's not do that. Case dot value. Oh, and then we resolve it. Right. As long as we set prev b to the first block, b should still be correct. Yeah, I just want to add the I'm gonna do this. I'm gonna add the same hack. Index. And if index equals 0, we're also gonna set it just in case. And then if we never hit, this is the no commit hack for broken fees emitted by IR inlining currently. Cool. And then where we were failing was CFG is not computed. Gen program 591. Whoops. Line 591. Function body. Unit body. We try to run CFG simplify. Why? Just because we haven't. Why don't we compute the CFG when we compile? We should do that. Because we're going to need it. We now need it. Let's just do it. Is it not reachable? So now everything coming out of compilation is going to have a CFG computed. Okay. Let's just move this into finalize unit. Ha! calling it in here. Good thing too. Oh no, we finalize. And then we insert it. Damn it. Okay. Finalize needs to insert it. And then, yeah, like, finalize needs to insert the thing and call gcompute and validate. That's fine for now, since we've added that. Validate unit. Do we not have a unit ID? We should let a unit ID earlier. Oh. That's all the time I have. So thank you. Whoever's watching, anyone watching later. Yeah, actually good progress. We figured out the core problem with trampolining, re-enabled it, got everything passing, running with the optimizations on. Now we just have a lot of tidying up to do. And yeah, I think it's in a great spot. Thanks for watching.